All right, for practice 1, we are going to work on calculating the different components in an ANOVA table when we have repeated measures. So as a description of the data that are in the practice 1 spreadsheet is that an exercise physiologist measured VO2, or VO2 max, in milliliters of oxygen per kilogram per minute for 5 subjects on a treadmill in a graded exercise test. After 3 minutes of level walking as a warm-up, the workload was increased every 2 minutes for 10 minutes. So they ended up having a total of 5 VO2 max measurements per subject. We can go over to our data spreadsheet, and the general instructions that we have are to fill in the ANOVA table given the information that we have. Some helpful tips that might be of use to you. Any references to the equations I'm using to do the calculations in the ANOVA table are in the first PowerPoint for this week in slide 5. As a reminder, degrees of freedom. If you watch the pre-recorded lectures, there was a typo, and I don't know if I clarified this, but there is a small n and there is a large N. So small n is referring to the total number of subjects. T is going to refer to the number of groups we have. N, or big N, is going to represent the total number of data points that we have. So I believe I must have misread my notes when I was going through the lectures and put a big N instead of a small n, didn't make that distinction. So we'll go through that in our data set so we kind of, brush off any confusion that there might be. So in our data set, we've got our VO2 max values for each minute of exercise every 2 minutes for 10 minutes total. And I've given you guys an ANOVA table very similar to last week. The only difference is that it's set up for repeated measures, where we've got a row for our conditions, or the groupings of our independent variable, a row for our subjects, or the variation that we would expect to see across subjects. We have a row for error, and we have a row for our totals. You guys have been provided the sum of squares for conditions, subjects, and total because we don't, well, at least I don't require you to know how to calculate those. Total sum of squares should be the sum of all of these sum of squares put together. So we can easily identify the error sum of squares by subtracting conditions and subjects sum of squares from the total sum of squares. So to do this, we can just do equals total minus conditions minus subjects. And then press enter, and we get the sum of squares for our error, or residuals. Now, to calculate the degrees of freedom, we need to know a few bits of information. The first thing we need to know is the number of subjects that we have. So this is denoted by small n, and belongs kind of in the subjects degrees of freedom calculation as well as the error degrees of freedom calculation. So we can see from our data over here to the left that we have 5 subjects, so small n will equal 5. The number of groups that we have is going to be based on the time points that we are collecting, so minute 2, minute 4, minute 6, minute 8, and minute 10. So that would be 5 groups total. And then the number of data points that we have, you can calculate this one of 2 ways. You can multiply your number of subjects by the number of groups, or you can do a count function and just highlight the data. Either way, you'll get the same answer. So use whatever method you can remember the best. For our conditioned degrees of freedom, this is going to be looking at kind of like between group comparisons or between each minute that we've collected. So to calculate degrees of freedom for conditions, we will do the number of groups minus 1. Our subjects, or degrees of freedom for subjects, will be kind of similar, where we're looking at total degrees of freedom across the subjects. So we're going to use the number of subjects minus 1. So we do equals number of subjects minus 1. The error is going to be the degrees of freedom between conditions as well as within subjects. So we calculate this by doing t minus 1. So you could calculate this a couple different ways. T minus 1, you could insert in parentheses and then multiply it by n minus 1, also in parentheses. We did already calculate t minus 1 and n minus 1. So you could just do a cell reference for the conditions degrees of freedom and then multiply it by the degrees of freedom for your subjects. Either will give you the same answer. For our total degrees of freedom, we're going to take the total number of data points that we collected and then subtract by 1 to get total 24 degrees of freedom. Our mean squared calculations are going to be the sum of squares divided by degrees of freedom in their respective row. So we could technically just copy this because each sum of squares and each degrees of freedom should shift as we copy. Our F statistic for our conditions, this is the F that we end up getting a p-value for in our one-way repeated measures ANOVA in SPSS. So this is the between group comparison, or looking at how each minute of exercise is different from the other if they are significantly different at all. To calculate this, we do the mean square of our conditions divided by the mean square of our error, which is similar to within group comparisons. The last thing we can calculate in this ANOVA table is the F statistic for the error within subjects. So we could do equals the mean square for our subjects divided by the mean square of our error. If you get the right answers, your boxes in your table should turn green. So this would be a good sign that all of your calculations went smoothly. So from here, all you have to do is copy and paste this table into the answer sheet, and then we will see you in the next video for practice 2.